Imagine you're floating in space, calm, weightless, and in front of you is the darkest thing in the universe. Not black like the night sky, black like a hole cut out of reality itself. You decide to fall in. What happens next is one of the strangest journeys physics can describe, and almost nothing about it will go the way you expect. So let's actually do it. Let's fall in, and let's find out, step by step, what a black hole would do to you, and why the answer is stranger than science fiction. First, what even is a black hole? Take something massive, a giant star far bigger than our sun. When it runs out of fuel, it can no longer hold itself up. Gravity wins. The core collapses, crushing an enormous amount of mass into an unbelievably small point. The gravity around that point becomes so strong that past a certain boundary, nothing can escape. Not a spaceship, not light itself. That boundary has a name, the event horizon. And it's the line we're about to cross. As you start to fall, you feel nothing unusual. That's the first surprise. There's no wall, no barrier. Falling toward a black hole feels exactly like falling anywhere else. You just keep accelerating. From your point of view, everything seems normal. But for someone watching you from a safe distance, the story is completely different. To them, as you approach the event horizon, you appear to slow down. Time near a black hole runs slower. That's not a trick. That's how gravity bends time. So from the outside, you seem to freeze, hovering at the edge, your image getting dimmer and redder until you slowly fade from sight. To them, you never quite fall in. You just disappear in slow motion. But to you, you sail straight through, and here's the part that breaks most people's intuition. Crossing the event horizon of a large black hole is not dramatic. There's no flash, no boundary you feel. You might not even know the exact moment you crossed the point of no return. But you did. From here, every possible path forward leads deeper in. Even light pointed straight up falls back down. The way out simply no longer exists. Now gravity starts to get personal. A black hole pulls harder on whatever is closer to it. So if you fall in feet first, your feet get pulled harder than your head. The closer you get, the bigger that difference becomes. Physicists have a wonderfully grim name for what happens next. They call it spaghettification. You get stretched, longer and thinner, like a strand of pasta, while being squeezed from the sides at the same time. For a small black hole, this would tear you apart long before you reach the center. But, and this is strange, for a truly giant black hole, the kind at the heart of a galaxy, the stretching near the horizon is gentle at first. You could fall well past the event horizon completely intact, still alive, still falling, with the universe warping around you. The bigger the monster, the softer the welcome. The stretching only becomes deadly later. So what would you see? Look back the way you came, and the entire outside universe is squeezed into a shrinking, brilliant circle of light above you, bent and distorted by the black hole's gravity. Some physicists think you'd even see light that has looped around the black hole, letting you glimpse the back of your own head. Everything is twisted, blue-shifted, unfamiliar. You are seeing a view no human has ever survived to describe. And then there's the center, the singularity. This is where our physics stops working. According to the math, all the mass collapses to a single point of infinite density. But infinite is usually nature's way of telling us our equations are incomplete. The truth is, no one knows what's really at the center of a black hole. To find out, we'd need a theory that combines gravity with quantum mechanics, and we don't have one yet. The singularity is, quite literally, the edge of human knowledge. Which brings us to the deepest mystery of all. If everything that falls in is crushed and lost forever, what happens to the information about it? The atoms that made you, the story of who you were. For decades, the greatest physicists alive argued about this. It even has a name, the black hole information paradox. Some think the information is destroyed, which would break the laws of physics. Others think it's somehow preserved, smeared across the black hole's surface, or slowly leaking back out over unimaginable spans of time. The debate is still not fully settled, because black holes aren't quite eternal. Stephen Hawking showed they very, very slowly leak energy and shrink. a whisper of radiation at their edge. Given enough time, far longer than the current age of the universe, even the biggest black hole would evaporate completely. So in the deepest future, the question isn't just what happens to you inside, it's what happens to the black hole itself, and whether anything of you ever comes back out. So, what would happen if you fell into a black hole? You'd feel calm, then weightless, then strange. You'd cross a line you could never feel and never uncross. You'd watch the universe fold into a ring of light above you. And then, depending on the size of the giant you chose, you'd either be stretched into a thread of atoms or fall gently toward a center that physics itself cannot yet describe. A black hole doesn't just end your journey, it takes you to the exact place where everything we know runs out, and the questions begin. If you'd want to know what we'd actually see if we could send a probe in and get the signal back, that's the next video, and the answer surprised even me. So subscribe, and I'll see you on the other side of the event horizon.